Hello, my name is Jamie Moyer. I am a premier field engineer dedicated to supporting System Center technologies. Today I want to talk to you about content replication in Configuration Manager 2012. We're going to go through the understanding of content replication and go through a lot of troubleshooting scenarios with content replication. The following conditions and terms of use, as well as copyright and trademarks, apply to the following content. So today we're going to talk about, like I mentioned, content distribution in Configuration Manager 2012. We're going to take a look at the components involved, we're going to look deeply at the content library, and finally we're going to do some troubleshooting. So why should you watch this video? Watching this video should give you a better understanding of how content replication functions in Configuration Manager 2012. You should understand which components are involved with the process. You should understand the flow of events that take place from the CAS to the primary to a remote distribution point when you create a new package or when you redistribute a package. And as we begin to go through the in-depth view of this process and we review specific scenarios related to common issues, you should be able to more quickly diagnose and remediate issues with content delivery in Configuration Manager. Okay, let's drill in. In my lab environment here, I have a very simple 3-server environment. I have a central administration site with a site code of 00A. I have a primary site of 00B attached to the central administration site. And off of my 00B primary site, I have a single distribution point attached to him that simply houses the distribution point role. All of these servers are running Windows 2008 R2 and currently running Configuration Manager 2012. This session is not intended to be an overview of the different types of packages and applications in Configuration Manager 2012, but just for context, everything we talk about here in relation to content distribution will be the same whether we're dealing with applications, packages, software updates, or operating system images. Replication by and large happens the same, with a few differences, slight differences we may touch on in the presentation. The first thing I'm going to do here in the demonstration is create 2 sample packages, Shared Package 1 and Shared Package 2. Both of these packages will have the exact same content. I'm going to do this procedure to first of all walk through the creation of a package, or second of all walk through how content delivery is affected when 2 packages share identical package sources, and specifically how that relates to the content library and the single instance store. So I've created my 2 packages. You'll note here in the console I have a Shared Package 1 and Shared Package 2. The package IDs ending in 026 and 027. If I go to my SMS logs directory and open up the Distribution Manager log, you can see some information related to these 2 packages. I always like to take the package ID, go to the Tools menu, select Highlight, paste in my package ID in question to get a vibrant view of everything that's going on with that particular package. I can see here that the first thing the Distribution Manager component did was reach out to the source directory and create a snapshot for the package. I see that it created a package signature and calculated signatures into the current version of the package is 1. It stored some information in the database, and it hasn't done anything else at this point in time. If I scroll up, I should see the same thing for the package ending in 0026, which was our first shared package. So now that we have our test packages created, what I want to do here before we go into the process of actually targeting them to a distribution point in question and monitoring them throughout the distribution process is give you a high-level overview of what's going to go on here and the different components involved. So from the central administration site, the CAS, in my environment, site code 00A, there's going to be several components involved at a high level. The SMS provider is going to be the component that's involved, so anything you do through the administration console is going to be logged and take place through the SMS provider. The Distribution Manager component, which we just briefly looked at the log file there, has a significant role in the process. And then Scheduler and Sender. Down in the primary is going to be similar, except the despooler component is going to pick up information sent from the CAS. He's going to create some work for Distribution Manager. And finally, Package Transfer Manager is going to be the component responsible for actually transferring the content to the remote distribution point. From that point, the SMSDP provider will pick up and do his job. We'll drill into more of these features as we go along. This is meant to give you a high-level picture in your mind of what we're going to be looking at. So now that we've got our two packages created, I'm going to go ahead and open up here in the Configuration Manager Trace tool the relevant logs that we'd like to see data take place in. There's an option, if you go to the Open menu, to say Merge Selected Files. So in our case, if you remember from the previous slide, we're going to select the components that we're interested in monitoring. Distribution Manager, Scheduler, Sender, and in this particular case, the SMS provider on the CAS. We're going to go ahead and select Open, and it will take a few seconds depending on the size of your log files, but they will all be merged together. And this is a very useful means in which to view a sequential series of activities in Configuration Manager. Due to the fact that there are so many components involved in Configuration Manager, if you look in the logs directory here, if you're familiar with the product, you'll note we have a lot of different components involved, lots of log files, and it's easy to become confused or not know which log to look at next. So being able to merge the different logs in the Configuration Manager Trace tool is highly useful. And now that we have the logs merged, you'll note in the title up here, you see the combination of the merged logs. You'll also note that it's easy to distinguish which component is being logged in the log due to the component column in the Configuration Manager Trace toolset. Okay, so now we're going to add the shared package 1 package ending in package ID 26 to our remote distribution point underneath our primary site 00B. So we'll select the package in question and select the distribute content option. We'll go through the wizard here very quickly. We're going to pick a distribution point. In this case, I only have a single one in my environment. And simply finish out the wizard. Now in this case, I've got the Configuration Manager Trace tool opened. And remember, we're targeting the components that are involved at the CAS and content replication. I've chosen in my Tools option here to highlight the package ID in question. Remember, the first thing that we said would happen here is the package ID in question. The SMS provider would first do its work. We see that here, that we've added a distribution point for this package ID in the SMS provider. Secondly, we see the Distribution Manager component pick up some action here. We'll see that it's instructing that it needs to send a compressed version of the package to site 00B. We have some information here about which drive it's going to use for compressing the package. We'll see, very important here, that we've created a mini job now to send a compressed copy of this package to this site. And if we look over here, we can see the transfer route and that we're currently at version 1 of this package. So what's happening right now is the package is being compressed. And once the package is compressed, we see a job here in the SMS Scheduler component for that particular package. We see, in my case, this package is very small, so the compression happened very quickly, that the total size of this job is 4K, and it is in a status of pending. Next thing will happen is the LAN sender component will pick this up and actually send the files to the remote site to the dspooler.box receive inbox. Finally, we'll send a completed status message when we're complete. You'll notice that the job is now in a working state as we continue to cycle through the log here. If we go to the primary site beneath the central administration site, 00B in my case, I've opened up the Configuration Manager Trace, and I've opened the dspooler log, Distribution Manager log, and the Package Transfer Manager log. You'll note here an error. This error is fairly common if you have a very fast lab environment, as I do. And the error is in the dspooler component that it has picked up the compressed file that we just saw send from the CAS. However, it hasn't received replicated information for the instruction file yet. This will retry in a few minutes and will succeed without error. So if you see this in your environments or in your customer environments, in a very fast connected environment, don't be alarmed. This will be a self-recovering error, as we'll see shortly. We can now see it's been a few minutes since the error here, 5 minutes to be exact. We've now validated the instruction file from the dspooler.box receive. Signature's OK. We have some information that we received this package ID, version 1. Here's the compressed file. This compressed file, this PCK, is actually only temporarily stored in the SMS PKG directory, and it will be deleted, unlike ConfigMgr 2007 and previous versions. It's only kept as long as it's needed to unpack the content to the content library. So you see here we're uncompressing it to a temporary location, extracting the contents of the package. So the package contents have now been successfully stored in the content library, which we'll drill into a little bit more later, on this primary site. Next in store is Distribution Manager knows that he needs to send this package to a remote distribution point. In my case, the server name is DCS-ORCH02. So Distribution Manager actually attempts to connect to the remote distribution point, verify the virtual directory exists there, and finally he's going to actually create a package transfer job to send the compressed version of this copy of this package down to that server. However, the Distribution Manager component is not the component that actually does that. As you'll note here, we move into the SMS Package Transfer Manager component. You'll see that it's now in the processing jobs phase. He's found a new job that he needs to send for this package and this version to the remote distribution point. He's in a state of pending at the moment. And what we'll see here very shortly is he's going to begin to send the contents of this package. In this case, is a legacy package because we actually created a legacy package in ConfigMgr 2012. He's going to actually connect to an SMS_DP $share on that system. And he's actually writing to a temporary location here under SMS_DP $share on that remote distribution point. Now this will happen very quickly because, as I noted, this package is very small. We'll see that this actually completed sending within just a few seconds, and we sent a status message to the Distribution Manager that we were successful. Here we go. Successfully updated the package status on the site. You see the job is now in a working state. Should finish up here very soon. Next we'll have a look at the actual remote distribution point. Okay, so on the remote distribution point, in my case I only have a local drive named C. There should be an SMS_DP $share. In that folder we have an SMS folder /logs directory, and we have an SMS DP provider.log. In my case, if I go down to the package in question, I can see that the content for this particular package has been added successfully to the content library. On the remote distribution point, there are not actually any services running for Configuration Manager, other than if you have the client software installed. Everything actually happens through a provider in WMI. So if I connect to the namespace root/sccmdp on the remote distribution point and do a recursive enumeration of the classes involved, I'll see several classes that are surfaced in this namespace. For example, SMS_packages in Content Lib. If I go to this particular instance, I can see that in my case there are 8 packages stored in the content library on this system. The SMS_distribution point class has several methods exposed, and these methods are how the Package Transfer Manager communicates with this component. You'll notice things like add file, configure pixie, create registry key, expand content, expand pixie image, get content hash. Several methods here in this class. I've run into in situations with my customers where, for one reason or not, due to WMI corruption or a process doing deletions, that the WMI namespace root sccmdp becomes either corrupt or deleted. It's easy to get that back. If you go to the same directory under the SMS_DP/SMS folder, in the bin folder you'll see a moth file called smsdpprov.moth. If your classes are gone and you need to get them back, you can very simply utilize the mothcomp command to get them back. So simply navigate with a command prompt to that directory. In my case, I'm going to do mothcomp smsdpprov.moth, and the data will be recreated in the repository. And to show you very quickly that it works, I'm going to go ahead and delete a class. I'm going to say SMS_distribution point, and it should be gone. So if I enumerate classes again, do recursive enumeration, you'll notice I no longer have an SMS_distribution point class. If I run my mofcomp command again, close out here, do another simple enumeration, I should have my class back. Now you can see I've got my methods and my class back in store. So if we go back to our CAS and go to the monitoring pane under content status, and I filtered it to my shared package here, you'll note that I targeted 1DP for this package, and that it's now 100% compliant, since we saw, in fact, that the package did successfully unpack on the remote distribution point in question. So the next thing that I wanted to look at was the content library. Brand new to Configuration Manager 2012. The content library is a single instance store comprised of a data library, a file library, and a package library. Let's take a look and see what it looks like. So I'm on my central administration site, and I'm in the C/SCCM content library. The location can obviously differ depending on the drives you have available on your server. If you need to find out where the content library is located, you can look in the registry under Local Machine Software, Microsoft SMS DP, and there is a content library path string value. So, as we said, it's comprised of a package lib, file lib, and data lib. If we drill into the package lib, we'll see an ini file for every package ID that you have. In our case, let's have a look at 0026, which, if you remember correctly, if we go back to our software library, 0026 is our shared package 1. If we open up the ini file, we'll see simply that there is a packages section which lists the package ID, and there is an info section which lists the version, and finally the flags. That's all you're going to find in the package lib. Just basically a definition of the current version of the package. Now, if we go to the data lib, we'll see a folder for each package by version. So if we look for our particular package in question, 0026.1 for version 1, and we open it, we'll see the files that are contained within the package. But in this case, they're all ending in .ini. If we were to browse back out to our package sources share, let's have a look at what the source of this actually looked like. Go to our content demo, shared package 1, and you'll note that we see all of the package contents for this particular package by name, at least, except that they're ending in ini. If we were to open up one of these files, we'll see that it doesn't in fact have the file contents. Instead, it has some information about the file. Attributes, the size of the file, the last time it was modified, and the hash value for the file. Now the hash value is critical. That's how we keep track of which files are unique. So now, we've learned what the package library is, we've learned where the data library is, and the file library is where we actually store the binaries in the single instance store. So in this particular example, we found that this file, new text document, has a hash starting with echo3 bravo 0. That's important because in the file library, it's organized into folders, and the files will live in the folder based upon the first 4 letters of their hash value. So in this case, we want to look for echo3 bravo 0. So if we scroll down here in our list, see if we can find it quickly. Oftentimes it's easier to search, but I just want to give you an idea of the contents that are in this folder. Okay, so I give up. I'm going to simply search for it, echo3 bravo 0, and we can see that we found it. So if we look in here, you'll note that the actual binary itself is here. In our case, we have a 0-byte file, but the file itself is not stored as the file name since it can be shared among multiple packages. Instead, it's stored as the hash name. Here we can see the different packages that reference this particular file. You remember that we have a shared package 1 and a shared package 2, and they both happen to reference this same binary. And you'll see that denoted in the ini file for this particular content. So that gives you a very brief overview of how the single instance store works, what type of data we store there, and where we store it. So what does that mean as it relates to package distribution? Remember, we haven't targeted shared package 2 yet to a distribution point. But also remember that they both share, from a package source perspective, in their source directories, the same source files. If we look in shared package 2, shared package 1, they're the same source files. So let's go ahead and add this particular content to a distribution point. Go ahead and say deploy. In this case, I don't actually want to deploy. I want to distribute content. Going to select my single DP once again. You'll note that you see that we assigned the package to a distribution point in the SMS provider log here. We're now on our child primary site. On our central site, you'll notice that the job was successfully queued up and sent to the child site, just like the first package was. On our child primary, you'll note the same error we saw previously, that the compressed version of the package arrived before the SQL replication took place. So that's normal. In my case, I've gone ahead and used the Configuration Manager Service Manager tool to temporarily stop our Distribution Manager component, because I wanted to show you something quickly as it relates to the content library. If we go back to the root of our content library, let's have a look, see what kind of information we have here. You'll note that on our child primary, we don't have any information yet about the 0027 package, because it hasn't arrived here yet. We do have information about the 26 package. If we drill into here, we'll see that he's at version 1. If we go to our data library directory and look for that same version, we see the contents again, the ini files destined for this particular package. Let's go have a look at one of the files in the file library. So we go to our file library, we search for a folder beginning with this hash. We'll see that we have a folder in there, and let's have a look at the ini file. So right now you'll see that this particular file is only associated or referenced, as far as this content library is concerned, with a single package. That's expected. Now we'll see how that changes when we get that replication down here. So the despooler component has now successfully uncompressed the package. Now we're looking here in the SMS despooler component. We don't get a lot of information here. We see that it's uncompressing from the PCK location to another temp location, and then that we're extracting from that temp location. So what I've done here, to give you a little more detail as to what's going on, is I've done a process monitor trace while that was taking place, because I wanted to give you an idea of how the information gets from the compressed file sent from the CAS into the content library. So you can see here, we're reading from that temp file here, and then we're actually creating a temporary directory, or we're extracting right to the file lib location. So in this particular case, we're actually doing a create file in the file library for that file. If we scroll down, you'll see more information about the unpacking. See a temp directory here we're utilizing, and you can see we're actually placing files, close file, create file, in the file library. You'll note in this particular instance that we created the ini file in the file library, and this is a file we looked at recently, I believe, the A8E8. If we actually open this entry and go to the file, copy that, start run, paste that in here, and open this up in Notepad, we'll see that now the content for this particular file is now associated with both the 26 package and the 27 package. As we scroll down further, you'll note that we actually create the entries in the data lib content directory, and the file lib, some more entries going on there. And finally, I saw the package lib as well. So now if we went to our package library here on our 00B site, we should have our 0027.ini entry in there. So you'll note that my log is stopped at this point, and that's because even though this package is targeted to my remote distribution point off of this site, I've stopped the package transfer manager component. I did that to show you briefly the job that was created as noted by distribution manager. Created package transfer manager job to send the compressed copy to this particular DP. If I go to the inbox for package transfer manager, I'll notice there's a job file sitting in the inbox. Now, if you open this, you can't see much information about the job. However, you can get a general idea. So in this case, it's package distribution job for shared package 2, for this package ID, for this distribution point. And a little more data about the package. You can see the version there. Go by quickly, version 1 of the package. So when we start the component up, if we go back to our component manager here, right-click on this query, it's still stopped. I'm going to go ahead and start this component and go to our log here real time, and we should see it find that job here fairly quickly. Okay, so you'll note that we just found the job. Here's the job file. It's being activated. It needs to send this package, version 1, to this distribution point. Current state of the job. There's some more information about the package file. We're doing some pre-actions. And finally, that we're going to be sending legacy content. Now note here, these not copying information here. Not copying any of these files to the distribution point. So, remember the content library is a single instance store? What just happened here? We don't have a lot of detail in our log file, but a process monitor trace displays what did in fact happen. We know that since shared package 1 and shared package 2 have the identical files, that the actual binaries for those files are already distributed to our remote distribution point. But remember, some things still have to change there. We don't have to send the binary because they're identical, but we have to create the entries in the other folders, namely in the package lib and the data lib. So if I go to my remote DP, which I'm on now, I go to my package lib, I'll see that I have the ini file for my 27 package. And if I go to my data lib directory, I should have a folder in here for 27, and in fact, I do. If we go check one of these out in our file library, let's have a look to make sure that the content there was updated as well. So if I go back to my file library and I do a quick search for that folder, see I found it here, and let's look in our ini file, you'll see again, in fact, that it knows that this particular file references these two different packages. So the important thing to note here is that the site that has the remote distribution point will actually, in real time, reach out to the remote server, to the content library share, query information out there, and create files as necessary. But it will not create a file that already exists, thus saving you the network bandwidth that you would have had to use to get it there, and intelligently using your disk space. Now in the SMS DP provider log on the remote DP, we'll simply see an entry saying that the content for this package has been added to the content library successfully. And if we look back on our CAS site, we'll see that we have, under the monitoring node for content status, that we are in fact 100% compliant. We've targeted one DP, and we've gotten the content there with a source version of 1. Okay, so we've learned a lot about content replication, the different components involved. We've created some packages on the central administration site. We followed them down through the hierarchy, down to a remote distribution point. That's when things were all working good. So, armed with that knowledge, we're going to take a look at what happens when things go bad. Now, I've done some things intentionally here to cause a content hash mismatch on a package I have called Del drivers. You'll notice here that in the console I'm looking at the content status node. I've got a DP targeted, and I've got a 0% compliance. Let's drill in and view the status. If we go to the error page, we'll see the status is that the content hash is invalid. We have a little more details here in the description. So, what did I do to break the package? If I go to my primary site and look at the package transfer manager log, you'll note that the error here we see is the hash did not match for copied content. So what I did, if we go to look at our content library real fast, SCCM content library, we look at our package library. If we go to the package ID for the package in question, you'll note that there are several different contents for this package. It being a driver package, this is a bit unique. So let's find this first one. Package ID starting in B64. If we go up to our data lib directory and we look for the B64 ini file, we'll see that there's a hash value associated with it. What I simply did was change this value from a 9 to a 2. Now, it's important to understand how this file is used. This hash value in this file is what is used by the remote distribution point, or any distribution point, to calculate a hash. Let's drill into that a little bit. So, Package Transfer Manager, we learned earlier, takes all the given files for a remote DP and copies them there as necessary. What we didn't talk about is that when it's finished copying the files for a given package, it instructs the remote distribution point to do a hash check for that content. If the hash check fails, you'll see an error message like this reported in Package Transfer Manager. It will then update the status messages in the database and set the status of the package to be failed. If we look at our database, I've got a quick query here, the package status disappoint summary table, and you'll note that our package is in a state of 2 and the install status of retrying package installation. Let's go have a look at a remote distribution point. I wanted to show you a tool that you can use on the remote distribution point to quickly check the hash on a given package. In the smsdp$/sms/bin directory, there's an executable called smsdpmon.exe. You can give this executable the parameter of a package name, and it will go out and evaluate the package hash of that package real time. If I go ahead and run this against our package in question, you'll see that I can see immediately that the hash does not match for this package. There are also other ways you can check the hash of a given package. Note the several methods here that you can do content validation. This is not meant to be all methods. These are just a lot of the different methods available. We just looked at checking the hash of a package with smsdpmon.exe in the package ID. You can also do it in the console on a specific package. There's also a WMI method on the distribution point, and I have some sample PowerShell script here that will allow you to do that check as well. Finally, there's a verify package method on the SMS_distribution point class that you can call via the SDK. Here's a quick example doing the test with a WMI method on the remote distribution point via PowerShell. I've created 2 variables, a hash algorithm and a hash algorithm, content ID, and a hash ID. I'm connecting to this namespace, this class, and I'm calling the method getContentHash for this computer name. If I execute that, you'll see that I get a hash value returned. In this case, 2EAB7. You remember we passed in 3 different parameters to this method. Let's take a look at which content ID we actually checked. In this case, we checked the content ID that I mentioned that we changed the value on earlier on the primary site. Let's go to our data lib directory on this remote distribution point and have a look in that file. You'll notice that the hash in this file is similar to this one here, except it ends in the A9, and that's what we actually changed it to on the primary site, forced to redistribute, and now we're getting hash mismatch errors. So again, this method here allows you to actually check to do a real-time calculation of the hash value and return what hash is calculated. If I were to change the value to the correct value in my data library and run this method again, It's not going to change what I return because this is actually checking the files in the file system that are referenced by this package. However, if I change that like I did, and I now do another content hash check, SMSDPmon, you'll see that I no longer get any hash mismatch errors. The content hash specified in the value in this file actually matches all the files on the disk. I mentioned that you can also do it via the console. In my case, I've gone to the software library, I've right-clicked on the package in question, and you'll notice I can see all the distribution points that the package is currently on by clicking the Content Locations tab. Upon selecting a distribution point, I can actually click the Validate button, which will cause a validation on the remote distribution point to take place and report the status accordingly up through the hierarchy. What's actually happening when you click that button in the user interface is this method that I referred to in the SDK. On the SMS_distribution point class, there is a method called verifyPackage. Let's go ahead and initiate an evaluation. If we look in the Package Transfer Manager log, on the primary site where the remote DP is based off of, we'll see the entry for starting validating of the package, and that a DP health monitoring task has been successfully started for the package ID in question. If we look on our remote distribution point in the smsdpmon.log, we'll see in fact the same time frame the job was kicked off, and that in fact a report has been sent to the management point. So now that we learned a little bit about hash checking, let's see how we can fix that problem in most scenarios. If we go to our driver package, select our distribution point, we'll notice that there's a button called Redistribute. The Redistribute button will actually cause a resend of all the packages, of all the files referenced in this given package to the remote content library. Now this scenario is different from what we looked at earlier when you create a new package, or the package transfer manager actually selectively sends based upon the file not existing in the remote library already, in that a redistribute will force the resend of the file even if it's already in the library. And it's meant specifically for situations like this where you have library content that has gotten out of sync. Now there are a few caveats that I've found out as to when I say, I should qualify, I guess I should say, that we will resend everything. The caveat is that when the check is actually made to determine if it will send a file, it checks to ensure that the file hasn't already been sent since the time that the Package Transfer Manager send request job has initiated. One thing I wanted to show you, like the Validate button, is what's actually happening when you hit the Redistribute button. If we go to the SDK, again on the SMS_distribution point class, we'll notice that there's a property here, a Boolean property titled Refresh Now. Setting this property to true on a package will in fact cause a redistribution. That's the method we're going to take here. So, we want to cause the redistribution of a package using PowerShell. I'm on my primary site. I have a PowerShell prompt open. The class that we want to target is the SMS_distribution point class. Let me do a get-WMI object just on that specific class, quickly. One moment. What I wanted to show you first is all the data that's returned from this particular class. You can see if we run this query, it's going to get all of the package/distribution points targeted relationships for the particular package and DP combination, for the particular package. So we need to scope the filter down on this to just the distribution point in question. Now, the way that you would scope it to a specific distribution point would be to actually filter on the server now path. In my case, I only have a single distribution point in my environment, so I don't actually need to filter all the way down to the server now path level. I can get away with simply filtering on the package ID. So, when I filter on the package ID, I'm going to actually put the contents of just the path property into a variable called $package. If we look at the contents of the $pkg variable, you'll see it's just a string value that points to the unique instance of this package/DP combination in the SMS_distribution point class. Now, I simply need to take and set that refresh now parameter to true. And I do that by using the set-WMI instance commandlet, passing the path of the $pkg variable that I just showed you we got from our previous command, sending a hash table of arguments with just the refresh now is true parameter. Say OK. Now if we watch our log file here on our primary site, very shortly we should begin to see a redistribute take place for that package ID. If you note on the object that was returned when we did the set-WMI instance, you actually see the refresh now property set to true. And you can see that in short order our resend has been initiated. Distribution Manager just created a job for Package Transfer Manager, and very shortly here the Package Transfer Manager component will pick up that job. As we see, a new send request has been created, and he will begin actually redistributing the files associated with that package to the distribution point in question. Very easily do it via the console, but I'm going to show you how to do that via a simple PowerShell script. One thing that I wanted to bring to your attention if you weren't aware of is the ability to do trace logging in Configuration Manager logs. If you go to the registry on the server in question, this is for site servers, primaries or CAS or secondaries, you want to look for Software Microsoft SMS Tracing, and there's a reg dword value called SQL enabled. Setting this to the value of 1 will enable SQL tracing. Now, what does that mean? It means that in log files where SQL is associated, we'll actually see the SQL statements that are being issued. This is very useful for troubleshooting situations. If we go to our log here and pause it, I actually saw several float by. Notice the additional information we now have in our log from the Distribution Manager component. For example, we can see the actual select statements that are being made. If there were update statements being done, for example, to the package status table, we would see that being made here as well. As you noticed, the setting took effect immediately. You don't have to restart the service. You simply set the value back to 0 when you're complete, and we'll stop our debug logging. So, our Package Transfer Manager job has completed to our remote distribution point. Remember, we redistributed the content. Now notice these entries here in the Package Transfer Manager log called not copying. This is important. I mentioned this briefly earlier, but this is a real example that may help drive it home. I mentioned that when you do a redistribute, it forces us to copy every single file back down, even if it already exists on the remote distribution point. But I caveated that with one exception. If the file version on the remote DP, for when it was copied there, is newer than when the actual Package Transfer Manager job started, we won't resend the file. So in this case, these files are likely duplicates in my package. And remember, since we're dealing with a single instance store, there's no reason to copy the same file down more than once if we just copied it within a few minutes ago. Now, let's go back. You see our sending content is complete here. Completing post actions, and we don't see any hash errors, so that means that this time our hash validated successfully on the remote distribution point. And again, if we go to the remote distribution point and look at the SMSDP provider log, we'll see all the references for the associated content for this driver package and that they were updated successfully. If we go back to the CAS and look at the actual status for that package, we'll see that in fact it is now successfully unpacked on the distribution point. Okay, so now we have a good understanding of how package content from a new package and from a redistributed package gets to the content library on a distribution point. We've looked at several scenarios. We've troubleshot an instance of a hash mismatch. We've examined the ways that we can do content hash validation. And we learned about how and when the Package Transfer Manager resends files. Let's drill into a little bit of a bonus here. I've written some PowerShell that actually does some comparisons between the content in a content library. Content library package compare script. So if you remember us looking at our content library a little bit earlier, is broken down into 3 sections: the data library, the file library, and the package library. If we start at the package library, let's look at the package that we've been working on recently, our driver package. If we go to this INI file, we'll note that there are several different pieces of content related to this package. The one that we've been working on recently is actually the B6 one down here in the bottom. Let's go find that over in our data library. So if we go to our data library, scroll down here for content, here's the file where we changed the package hash. So here's the hash that is checked against all the content associated with this particular driver content. Now if we go in the data lib directory as well, we'll see that there's a folder associated with that as well. And within this folder are all the actual files associated with this content. Now these aren't the files themselves, you remember. These are just simply information about the files, the attributes, the size, the time modified, and finally the hash of the file. In order to actually find where the file is, remember, you have to go to the file library based upon the first 4 digits of the hash. If we go to the file library, again we can see the files within here. The actual file name will be the hash name, not the file name. So I created some PowerShell that gives you a couple options here. It asks you which directory you want to evaluate, in which case this is the package ID, and it asks you the distribution point server name. Now, what's going to happen here? First thing that's going to happen is the script is going to go out to the distribution point that you placed here. It's going to connect to WMI. It's going to query a registry location on the distribution point to find out where the content library is for that machine. It's going to store that variable, the value of that variable in the content lib path. Okay? Next thing it's going to do is we're going to go out and sort of enumerate the content library folder structure just like I described to you in the user interface. And here's what you're going to get back. So I've already ran one here for my package ID 0025. And what we'll see is we have several columns that are presented back to us. The package ID, the package hash, and when we say package hash here, remember this is the overall hash. So if we go to our data lib directory and we go to our file in question, we're talking about this hash right here. So driver packages are a little bit unique and they have several contents, but we're talking about this hash right here. So we're going to tell you that. Then we're going to tell you each file name in the package, the actual path to the file. We're going to tell you the hash for that specific file. We're going to tell you what the size is expected to be per that file in the data library. The last time it was modified, the actual file size. Then we're going to reach out via the script to the actual file in the file library and get the similar information, the actual last time modified. And we actually do a simple comparison in the PowerShell to make sure that the size of the file on the actual single instance store matches the size that we say it is in the ini file. And finally, we'll actually tell you the actual file location for the file referenced. This would be useful in the scenario where you wanted to compare files on one content library to files on another content library for a given package to see the differences. In my case here, I've done that with a problem that I had, a similar problem that I recently ran into with a customer, and a problem that I really just demonstrated for you as well. In my case, I've connected one of these against my CAS and one against a remote DP. Now, if you look at the package ID here, you'll note the package hash value starting in 2E, ending in A2, versus this top server ending in A9. Now, the hash value should be the same for the overall given package. So, running the script and outputting to a CSV or Excel, or maybe even running some additional PowerShell differencing logic would allow you to quickly discern, based upon a given package, what the exact differences are between one content library and another content library. I hope this presentation on understanding the content library and troubleshooting the content library and content replication in Configuration Manager 2012 has been useful to you. If you have any questions or feedback, please feel free to reach out to me.